purpose of this video is to demonstrate Newton's first law talks about moving an object. Hi, I am Eureka White, and I'm going to be talking about Newton's second law. The purpose of this video is for any student that views this video will be able to calculate or predict the amount of force needed to move an object using Newton's second law. Before we get into Newton's second law, let's go back and revisit Newton's first law. So Newton's first law states that an object traveling will continue to travel until something stops it. And an object that is at rest will stay at rest until an object or unbalanced force moves it. So if you have an object that is traveling along at a speed of 20 meters per second, what would that object be doing 24 hours from now if no other force acts on it? Well, according to Newton's first law, it will still be moving, considering we have no gravity acting on it. Newton's second law states that the net force acting on an object causes an object to accelerate in the direction of that net force. So how do you calculate this force? So you have to find this equation, which I give to my students, which is F equals m times a. Force equals mass times acceleration. Newton's second law states that the acceleration of an object depends on the object's mass and the strength of the outside force acting on it. So if you look at this slide here, and you see the golfer, would it require the same amount of force to hit this golf ball as it would to push this truck? And the answer would be no. You will need more force to get this truck moving. If the forces acting on them are equal, who is going to accelerate more? Will it be Rudy or Fat Albert? So if you push Fat Albert with the same force that you push Rudy, Fat Albert, which is the bigger guy, is going to accelerate further. Now, in order to perform these calculations, I always tell my students that the best way to do this is to have the mass in kilograms, and acceleration must be in meters per second squared. Once you get the calculations, you must put an N behind the problem, behind the answer, because force is calculated in newtons. Okay, so how do we figure out the force? Using this equation, force equals m times a. If a problem asks you to find the acceleration, all you have to do is do some simple math, and now you have acceleration equals force over mass. If the problem asks you to find a mass, all you have to do is do simple calculations, and you will come up with the equation mass equals force over acceleration. Alright, so let's do a little bit of calculating. Let's read the problem. What is the acceleration of a 15 kilogram cow when it's pushed by a force of 300 newtons? So all you have to do is plug and play. First, you have to find the force. So we go down to the problem and we look for the number with newtons next to it, because because force is calculated in newtons. Next, we have to look for the mass. All we have to do is look for the number with the kg next to it, and then we come up with the acceleration. It's called plug and play. Now here are the steps Here are the steps to solve for any of Newton's second law questions. So that means if it's asking for the force, if it's asking for the mass, or if it's asking for the acceleration, all you have to do is take these steps. Now, the first step is to figure out what the problem is asking for. The next step is figure out what equation you are going to use. Third step is plug in the numbers into the problem, and all you have to do is solve. Thank you for listening. All you have to do is plug and play